We want to solve, this time it's the trig expression is tangent right here. We want to isolate this one. So algebra skills, as before, -5, -5. So now I have 2 tangent of x is equivalent to 2. Divide both sides by 2. Good. Now be careful here. You can do this or put this over 1. And I know tangent is opposite over adjacent. And opposite and adjacent being 1 and 1, there is a special right triangle associated with that. So as before, these are the angles. So I need to sketch possible locations for x. And if I do that, I'm going to be in quadrant 1, or I could be in quadrant 1. I could be in quadrant 2, quadrant 3, or quadrant 4. Make the right triangles associated with this. So I keep forgetting to put this, by the way, the x, or sometimes I forget. But this angle right here represents x. This is the terminal side. This one over here, I know x starts over here, but it's the reference angle for x, reference angle, and reference angle here. And then start labeling it. Opposite should be 1, adjacent should be 1. So opposite I'm going to label 1, adjacent 1, and do that for all of the triangles. Now the only thing is that when I do get here, what I want to do is make sure that you label the negatives appropriately. This because it's on the negative direction, -1. This one because it's downward, negative. And this one should be also negative. Now be careful here. Tangent is positive on which quadrant? First one and 3. So we're used to seeing them side by side, but it so happens that this one eliminates this quadrant 2 and eliminates this quadrant 4. And if you want to put a note, why? Because, not cotangent, because tangent of x here is -1 over 1, or just -1. And same thing over here. Tangent of x equals to -1. And we can put on here not positive, which is what we actually, or the problem required us, positive. And here's the tricky part right here that students get confused. Be very careful that you understand that here tangent of this reference angle, or of x, is going to equal to, opposite is -1, adjacent is -1, so a negative divided by a negative is a positive, so this one does work. So be careful with this sketch right here. Now, what special right triangle is this? 45, 45, 90. This is the square root of 2. You can confirm that with Pythagorean theorem. So this has to be 45 degrees and 45 degrees over here. Now remember, we want to start from positive x-axis. I rotate to this. I get this right here. That one's simple. That one's simply x equals to 45 degrees. And start back to the positive x-axis. Choose green, and I rotate until I get to the terminal side over here, and I end up with how many degrees here? 225, because again 180 plus a 45 gives me 225. Alright, so some of you wrote your answers already, and you wrote this, and which is perfectly fine. 45 degrees plus the 360 times n. Again, let's put n is any integer. And also x is equivalent to 225 degrees plus the 360n. If I convert this to radians, remember that 45 is pi over 4 plus 2 pi n. And 225, how many 45s fit in there? You can do that if you need to on the side, but it's 5 of the 45. 5 times 45 gives me 225. So some of you gave me those answers, and that's perfectly okay to give these answers. The only thing is that the textbook reduces these two because there's going to be a repetition if I write these two answers right here. And it has to do with our sketch. Let me go ahead and zoom in on this sketch right here, and I'll move back over there to the answers. But here, if I just use this 45-degree answer, this one right here, that's all I need. Because notice what happens with this symmetry. If I jump to this one, this other answer, how many degrees is that? 180. What happens if I go back to my answer? How many degrees is that? Well, but in that from here to here is 180. So 180, if I keep adding 180 to the 45, it's going to give me all these answers that I just gave. So sometimes the book uses this answer and says the following. They sometimes write x is equal to pi over 4 plus just 180, which is pi times n. The book simplifies both of these to just that one answer because of this symmetry that happens in the sketch. But let's look at where this comes from in terms of the tangent graph. If you recall the tangent graph, do you remember where the asymptotes are at for the tangent graph? Yeah, negative pi over 2 and pi over 2. And we had a graph between there. And of course, it would repeat itself in both directions. So the repetition, which is called the period, was how many units? Well, it's pi over 2 from here to the 0, and another pi over 2. So what's 2 pi over 2? 1 pi. So the period for tangent was pi, and you're going to see that if I repeat that anywhere else, it was always going to be pi units. And notice how on the cosine and sine, we really couldn't reduce this to the symmetry that we see here because the period, in fact, for sine and cosine was at 2 pi n. And that's why, when I would say on the other sections for the asymptotes, when we would write the asymptotes, when we would write the zeros, I would tell you, write the first zero and then plus the period times n. That's why you can see this is why this answer is generally preferred rather than these two answers over here, because if you give those two answers, you're kind of repeating yourself. And you can see that if you make a list. If you start making a list of these answers, you get 45. You add another one, you get 405. You keep repeating them. You're going to see that on this, on one of these, you will get eventually, they will eventually repeat themselves. Okay? So just FYI, the reason I'm telling you this one is because you may write your answers like this. I am okay with that. But if it's a multiple choice response, you may have to give this other answer because these may not show up. So just be careful with that. Questions?